At the end of your packet from class today, you graphed an exponential function, y equals 2 to the x, and then you took the points, some of the points from that function, and made the inverse of them. You flipped x and y, graphed those points, and got us a new curve with an equation x equals 2 to the y. And now the question arises, if I were to try to graph that equation on my calculator, it has to be y equals. So how can I make that equation be y equals? I can't divide by 2 because it's not 2 times y, it's 2 to the y. I can't minus 2 because it's not 2 plus y, it's 2 to the y. Essentially, the question we're asking is, what is the opposite of exponentiation? We know the opposite of addition is subtraction. Opposite of division is multiplication. Opposite of squaring is square rooting. But what is the opposite of exponentiation? So to get us there, I'm going to do something we rarely do as mathematicians. I'm going to take that equation, x equals 2 to the y, and write it out in words. Take a look at this equation and see if it looks like it matches up with the sentence. Y is the exponent with base 2 that gives us x. Hopefully you agree with that. So now I'm going to replace one word of this sentence with a synonym. So I'm not going to change the meaning of the sentence. I'm going to replace the word exponent with a brand new vocabulary word. And I've just replaced the word exponent with its synonym, logarithm. Y is the logarithm with base 2 that gives us x. A lot of times we abbreviate logarithm and just say log. So now I'm going to take this sentence and change it back into a mathematical equation. Y is or equals the logarithm, which I'll abbreviate with log, base 2, so I'm going to put a little 2 down here as a subscript that's going to serve as the base, that gives us x. This equation, y equals log base 2 of x, is the same thing as x equals 2 to the y. So I'm going to get rid of all of this and just move my new equation, y equals log base 2 of x, to go there. So those two red equations are the same equation. One of them is x equals, one of them is y equals. And they are both the opposite or the inverse of the green equation, y equals 2 to the x. Now let's just check this out on our graphing calculator to make sure log base 2 of x looks like our graph that we did by hand. In your y1, go ahead and type in our exponential function, 2 to the x. And then in y2, we'll try typing in our log curve. Now hopefully on your graphing calculator, you've noticed there is a log button on your calculator. It's right here next to the 7. Now this log button is log base 10, but the graph we want to do is log base 2. So to get that different base, hopefully when you go into your calculator's math section and you scroll down to the bottom, you've got something that says log base. So I'm going to press that, and there's what we want to put in. Y equals log base 2, so I'm going to put a 2 in the little subscript square, of x. Now, if unfortunately your calculator doesn't have that log base feature underneath math, you can type in log x, close the parenthesis, and then divided by your log base, which is log base 2. So I'm going to do log divided by log 2. Both notations are the same. So now when we hit graph, there's my exponential function, and there's the log function coming up there. Notice crawls along y-axis, and then once we get close to the x-axis, we start to curve up into the first quadrant. And this graph looks exactly like what you have as your paper graph in your packet. So if I have an exponential function that's y equals 5 to the x, the inverse of that as x equals would be x equals 5 to the y. And then as y equals, that's going to be y equals log base 5 of x. The two red equations are the same, and they are opposites of the blue equation. So essentially here, any exponential function I make, if this is y equals 8 to the x, my inverse equations are going to be x equals 8 to the y, which is the same thing as y equals log base 8